Geraldine, and thank you to the Big Dane organization for having me here today, and to TTS as well. So thank you for that introduction as well. My name is Jasminder. I'm a solution architect, which essentially means I help customers build things, build solutions, build prototypes, and experiment. I wanted to talk to you guys today a little bit about cloud computing, Amazon Web Services, and what we're doing and helping customers today. So let's get started. I always start with a very fundamental definition for everybody to make sure we're all on the same page about what is cloud computing. And this is a very generic definition which we should all know about. It's being able to use any IT resource on demand, being able to say that I'm going to use a server, or I'm going to use a workload, I'm going to use a service, and only being able to pay for however long you use it for. That's the fundamental definition of cloud computing. And it's essentially the tenet or the goal which AWS has been operating for over the last multiple decades. And it's important to know why this matters as well and why it's important. Customers all over the world have been able to use cloud computing to build solutions. And maybe, one of the key examples I always give my customers or anybody I talk to is Netflix. So if you didn't know, Netflix runs on AWS and has been running for many, many years. And the reason they're able to scale, I'm sure in Australia, you guys enjoy Netflix as well as all over the world, is that they're able to use global infrastructure. So they're able to use regions all over the world to run their videos, store the videos, and make it available to customers wherever they may be. And also within those regions, like within the Sydney region or within the upcoming Melbourne region as well, they're able to build solutions which are highly available, as in they don't go down even if there's a power failure somewhere. And the idea here is that you can build those solutions where you are located, but you can also export them and make them available to your customers or global customers in other parts of the world very, very easily, because all the regions within AWS are all the same. You might ask, so Jazz, what can I do? What can AWS do? What is this AWS thing, cloud computing? There are a lot of services, over 200 services available to you to use. Something as simple as you want to run Windows and you don't want to buy a computer, put it together. You just want to run Windows and you just want to be able to log into a Windows machine, install some applications. That is the most fundamental thing you can think of. Maybe next to Windows, you might say, I want to run Linux. Or you might say, I want to run a database. Or you might say, I want to build a machine learning model. I want to build an AI chatbot. So there are over 200 services and many, many capabilities which you can go and build solutions on. I always look at these services as Lego building blocks. It's there for builders to put together, just like putting together Lego, and build full, complete solutions. I'm sure a lot of you might be like, so who's exactly using these services today? So there are customers all over the world, big, small, startups, big enterprises, organizations from, again, I gave an example of companies like Netflix to Nike to NASA, JPL, to the ATO, the Australian Tax Office, to Tinder or to VMware. Organizations from every industry use AWS Web Services to run their workloads. So whatever industry you can think of, AWS is playing a role in helping that company, helping that organization run workloads. I thought of some examples which might help you understand or the scale of which we're talking about. And the first example I always thought of to give you guys was Fortnite. And I'm sure you have, if not played it, you have at least heard of Fortnite, which is a game which was built by a company called Epic Games, or a studio called Epic Games. And Epic Games used AWS to deliver or make Fortnite available to more than 200 million players around the world. And if people still play Fortnite today, I'm sure a lot of people do, they're still able to not only scale, grow to more than 100 times their size in just 12 months. That's the kind of scale which is expected and which AWS allows its customers to run on as well. That's one example. So they use a few services mentioned here, like Amazon EC2, which is Elastic Cloud Computing, and Aurora, which is a database service to run some of their services. Another example I thought which might echo with our audience is Gearbox software, which have created many good games, things like Borderlands 3. And again, so they use AWS to run their game platform, their Shift game platform. And again, the goal here is that because they need to support millions of customers and players at the same time, all coming from different regions and different parts of the world. So you might jump on and play a game with somebody who's located in Italy or in Japan or in the US or in South America, and you will have the same experience as they will be having as well. And this flexibility of being able to scale, to use resources in a region where the customer is located, and then also turn off those resources, which is very key as well. So not only being able to create computers, resources, servers, databases, but also to turn them off is very key to how AWS is helping customers stay flexible, and how you can think of ideas to stay flexible as well, so that you don't have to spend a lot of money upfront or being able to build for demand, which might be coming your way in the future as well. I know I gave an example in the past about the ATO, and for all of you guys, and I'm sure your families who have done their tax recently, you can imagine that during tax time, there is this window of time when there's, people all across Australia want to submit their tax returns. And so as an application, the ATO gets a lot of traffic coming their way, a lot of people logging onto their website, reading about the taxation rules and what to submit, and then submitting their taxes or tax returns online. So how does ATO scale? Do they buy all that capacity, all those servers ahead of time? No, they don't. They use Amazon Web Services to be able to scale. So that the ATO only use all that infrastructure, all that compute power only when they need it. And then after that peak demand has died down, they're able to turn off all those servers and only pay for what they used. Helping ATO save a lot of money, as well as giving the customers a lot of great experience. Now, a lot of you might say, Jazz, I thought this was a space or cloud computing conversation. What are you talking about ATO for? Well, the idea here is that within my business unit or within my group, we help space customers, and so we bring the cloud expertise to help our space customers build their solutions. And again, you might say, Jazz, how does that really work? I'm not seeing the connection between space, satellites, and AWS. AWS is very ground-based, or maybe you're running games. So how are you helping space customers? So I created a quick little diagram to kind of give you an idea about what a typical when you think about a space organization or a company, what might you come across? You might come across somebody who's designing a satellite or building it. You might come across somebody who's launching the satellite, organizations like SpaceX or Rocket Labs who launch satellites. Then you might come across somebody who's operating a satellite, and they're maintaining the satellite, making sure it's talking to the ground. And then they maybe need to download all that information, all those photographs taken from the satellite as well. Then they maybe need to do some machine learning, some analytics on those, and to give you guys insight. For example, what is the weather going to be like tomorrow as well? That's an insight you get every day. You get told the temperature is going to be this way, There's maybe a weather system moving in, and but we can do much more. We can do not only weather monitoring from space, we can do water monitoring. We can monitor our oceans, our coral reefs. I've been working with customers who have been monitoring bushfires from the moment a bushfire is observed, to being letting know. And I'll talk a little bit more about that later. We're also helping customers in the shipping and in the mining industry as well. But throughout this entire, what I like to call a value chain, there are services which customers are using every day, provided by AWS to help achieve their goals. That's a better way to put it, without being too technical as well. So I thought of more examples to give you as well, but I also wanted to inform you about something you can do. So if you ever have been curious about, can I talk to a satellite today? The answer is yes, you can. All you need is an AWS account, and you can use an AWS service called Ground Station, and you can communicate with a real live satellite. There are a lot of public broadcast satellites. For example, I can think of one called Aqua, which is available for anybody to communicate with. And these are run by NASA and other organizations as well, other research organizations. So the goal here would be that you can go on today on board the satellite, the public broadcast satellite like Aqua, onto your account, and then talk to the satellite and ask the satellite, hey, give me the latest satellite imagery you've taken in the last however many hours. And you can create your own satellite imagery from the last few hours, and that'll be something which will be yours. So it gives you an idea of how easy access to satellites is, and how customers can actually build solutions which are really, really quick. So Ground Station is just one service where you don't have to worry about building your own antennas, maintaining them, giving them power, connecting them to software and data centers. You can just come in and schedule a contact and say, I want to talk to this satellite at this time, and everything else occurs automatically. So you can download your satellite imagery and have a look at it at your own time, but the entire communication with the satellite occurs automatically. Another example is a customer called Capella Space, who provide access to their satellite data within minutes of its capture. So typically they saw that when they were operating previously, that their satellite data services were taking up to 24 hours to provide satellite imagery. But by using AWS, they were able to cut that down to minutes. So as soon as a satellite takes an image or its sensor takes a photograph, within minutes of that, they're able to make that data available to their customers on the ground. Again, I know we spoke about bushfires, which are very topical to Australia. We've had bushfires many, many times, destroy a lot of land, a lot of natural resources, and displace people. So one of my customers has built a fire monitoring solution platform, which is able to detect a wildfire within 3 minutes. So they've been able to make that very short, because they've realized that difference between a fire burning for 3 minutes versus a fire burning for 15 minutes is hundreds and thousands of hectares of land burnt, how many houses have been burnt. So it's very important when a fire is detected in a particular area, we tell our frontline workers where it is and what they can do as well very, very quickly. Another customer of ours, which was able to map the entire African continent, was Digital Earth Africa. Again, this organization used satellite imagery to put together continental wide. Now, I want to emphasize that as well. Australia is a very big place, but Africa, again, is a very large space. So when you want to take satellite images of such a large landmass, you have to take a lot of satellite images of small tiles of land. And then you have to stitch those tiles together to make one giant photograph, which we call a continental scale high resolution image. And again, all the computers, the servers required to do that would have been enormous if they were to be purchased ahead of time. But Digital Earth Africa used, again, AWS to put these high resolution images together within minutes of capture. So they were able to achieve this 800 times faster than what they were being able to do before as well, and able to help both the governments and people on the ground make use of that. Another one of the customers which I've been working with, I'm just going to play this video, has been helping demonstrate or build satellites of what we call digital twins. And they've been able to do that virtually because, again, during COVID, we are all impacted, and we know that we will not be able to physically go into the lab and build these satellites as well. But nevertheless, you can still, they're working on a platform which allows students and builders to build satellites and test them in a digital environment. And you can simulate all aspects of satellite. For example, how many solar panels they need to have, how large is it going to be, what orbit would you want to put that in, and what is the impact of that orbit as well, whether it's going to be a lower Earth orbit or it's going to be a medium Earth orbit. How is the satellite going to behave while it's doing that as well? What areas of the Earth is it going to be able to look at while it's circling around the globe? And you can simulate all of those things. Now, this becomes very important because you want to be able to test this ahead of time. Again, as you can imagine, with satellites, once you launch it into space, you can't really do a whole lot with them in terms of maintaining them or going to fix them. So testing and being able to simulate behavior becomes very, very important ahead of time. You want to plan for anything and everything which might go wrong ahead of time. And you want to make sure that when your satellite is launched and is in space, that you know exactly how it's going to behave, and you have taken into account every factor of satellite operations as well. So this is one example. One last example or idea I want to leave you guys with is that there's a registry of open data available. So if you've ever been curious about, I wonder what satellite data looks like, or I wonder if I can go and have a look at satellite data for free from different satellites. So there is, that is available to you. So at the moment, AWS hosts over 400,000 scenes of Earth imagery, or 200 plus terabytes of satellite data. And that's just from Landsat 8. So Landsat 8 is one satellite. Much like Landsat 8, you have access to Sentinel satellites, again, all of the Sentinel satellites, as well as many other satellites as well, of which the data has been made available to you for free. So I encourage everybody to go have a look at the registry of open data. The link is right there. All of these satellites, and you can just search for Earth observation or satellite, and it'll give you a huge list of all the satellite imagery available to you, and also how to access it as well. What you can do with it, it'll give you ideas about how you can process it, and also give you access to code. If you're not a developer, that's okay. It'll still tell you how you can use tools available online to achieve if you have a particular goal you want to achieve as well. With that, I want to close and open up for questions. And I've always been told, instead of asking, do you have any questions? It's much better to say, what are your questions? Because do you have any questions is a question itself, and somebody might say, I don't have any questions. But if I ask you, what are your questions, then I'm forcing you to ask me any questions as well.
Yeah. Thank you, Jazz, for that presentation. We have a few questions. Have you ever been to space, and have you built a satellite?
I have not been to space. I am helping customers build a satellite for different missions. I have built satellites digitally, but not hands-on. Again, building satellites is, I want to say, fairly expensive. But give me some time. There's many projects ongoing. I'll keep you posted on that one. I'd love to build a satellite myself, And I think that's going to be possible very, very, very soon as well. If a lot of universities in Australia are working across different projects, and if you want to get involved, absolutely, there are projects ongoing which are completely student-led satellite builds as well at the moment.
Yep. What did you study at university?
I studied electronics and electrical engineering at UTS. But that being said, I have to say that a lot of my learnings came from working in the industry hands-on and yeah, being able to really go away and learn different things from different industries, from different people. So going outside of what I had learned at university and being able to explore more domains.
Yeah. What is the best and worst career decision you have ever made?
The best career decision was possibly to, well, when I say making the move to come work at Amazon Web Services probably was the best career decision I ever made because it put me in touch with so many fascinating, sometimes feels like science fiction projects which are ongoing right now. And worst, to be honest, I will never say there has been a worst career decision because every decision you make ends up teaching you something. So it's up to you to how you respond to your choices. And so there's no worst decisions. There are only decisions from which you learn from. And if there's a choice you make and you learn from that, that's a good choice.
If I wanted to work at AWS, who and how is the best way to contact someone?
You can go to the front door, which is again careers.aws.com. There are open positions for so many different types. You can join as an intern. You can join as there are multiple positions. And again, you don't have to be you don't have to look for jobs only in Australia. You can actually apply for jobs in different countries as well. So if you see a role you like, you can apply to it. Feel free to reach out and talk to anybody from AWS as well. I'm always open, happy to reach out and answer your questions as well.
Yeah. What are your daily tasks at AWS?
Daily tasks. I'll tell you just from this morning. I had a conversation with some customers in Japan who are trying to build a satellite and they're trying to build a geostationary satellite, which are satellites which stay in one spot and look at only one particular part of the Earth. And they were asking us if we can help them monitor the satellite as it's traveling. So their customer is going to take about 7 months to take this satellite from low Earth orbit, that means after it's been launched, into its final position, which is just really, really far, far away. And that was my first conversation. My second conversation was with a customer who's looking to help a organization in Thailand. Again, Thailand has a few satellites which they want to start, I want to say, commercializing as well. They want to use the satellite imagery for much more things. So we're helping them. So the daily task is, my daily looks like having a lot of customer conversations, talking to customers, designing solutions for them. If they have a particular challenge, they'll say, how can we do this? How can AWS help us do this? And then I'll go away and think about and draw a solution or draw what a solution will look like. And then also build those solutions as well as prototypes.
Yeah. How should you write a resume that will appeal to Amazon Web Services?
Good question. I think AWS recruiters always look at the experience that you've gained. So if you're writing a CV, talk about, don't not only talk about your achievements, you should always talk about your achievements and the work you've done in the past, but talk about the impact you've made and whether that impact's been to the organization you worked at, whether that impact has been to society, if you've been doing extracurricular work and you've been teaching others or mentoring students or doing any extracurricular work, put that down as well. So try and reflect and quantify, write down what has been the impact of my achievements. And if we can do that, then that'll be taken on very positively at AWS.
Yeah. What do you find unique about AWS compared to other companies?
One unique thing is everybody I speak to at AWS, we are very customer obsessed. That is, we will go to the utmost length to help customers build their solutions. And a lot of times we'll imagine with customers what a potential solution might look like. If they have a challenge, we'll solve them. So that is probably one of the biggest things I'll say is that everybody at AWS is so customer obsessed that sometimes they forget about themselves, and it almost feels like they're not working for AWS, they're working for the customer.
Yeah. What is the best pathway to start a career at Amazon Web Services for students and graduates?
There's multiple pathways. An internship is always a very good pathway because it's very short and sharp. It's a 12-week engagement, which gives you a very, very good idea. It gets you very hands-on. You get to understand the entire business, how it runs, how it works, how we talk to customers, and how we build things internally. Another pathway is for graduates as well. There's intake programs which is called the Tech U program as well, which takes on students I think towards the end of the university as well, or in the final year in university, and then teaches them for 6 months everything about cloud computing and how to build things. And then they go on to do full-time roles after they learn them. So the multiple pathways.
Yeah. Unfortunately, we have time for one final question. What sacrifices have you had to make to succeed in this field, and do you feel the sacrifices were worth it?
Yes. Again, I feel sacrifice is maybe a strong word. Looking back, I would say it was a choice I made. And the choices I probably made are more about realizing the more you learn, the more you realize how much you don't know and how much more you need to learn. And constantly paying attention to yourself that I need to learn more things. And we need to continue to go set time aside for ourselves. So maybe it's not a sacrifice as such as to looking after your own well-being in terms of I need to learn more things. I need to experiment. I need to fail many times to be able to learn new technologies. I need to recognize what I don't know so I can go and learn those things. So again, it's not a sacrifice, but a choice I make. And it's a good choice. I'm happy to make that all the time.
Yeah. Well, thank you for your presentation.
Thank you so much, Geraldine, for having me. Thank you again for giving me a time today. I hope you have a great day.